This is College Algebra 2, Test Review 4B, Problem 9. An object is launched directly upward at 64 feet per second from a platform 80 feet high. An equation to model the height, h, at time t is given by h equals negative 16t squared plus 96t plus 40. When will it attain its maximum height? So you've got a... Oops, I'm not on my pen. Hold on. You've got a quadratic equation. It's a parabola. This is the shape of the object launch path, trajectory path. It's being launched from a place that is already 40 feet high. So it gets started right here. The first question, when will it attain its height? Right here is the maximum height the object will attain. Well, that's the vertex, okay? And the height is going to be the y-coordinate. So the x-coordinate is time, and the y-coordinate is height. So let's first of all find the x or t coordinate, and you're going to use the formula in standard form, x equals negative b over 2a. So negative b, that's negative 96 over 2 times negative 16. 2 times negative 16, I'm doing that on a calculator, is negative 32. So I've got negative 96 over negative 32. And now negative 96 divided by negative 32 is positive 3. Okay. All right, so at 3 seconds, it will attain its maximum height, but that doesn't answer the question. So let me just write 3 seconds here, and I'm going to erase to make more room. Okay. Now what I'm going to do is I'm going to plug 3 in for time. So h equals negative 16 times 3 squared plus 96 times 3 plus 40. That's negative 16 times 9 plus 96 times 3 plus 40. All right, negative 16 times 9 is negative 144. 96 times 3 is 288. And then I'm just going to add those 3 things together. Negative 144 plus 288 plus 40 gives me 184 feet. 184 feet. So that's the answer to question A. Question B, what will be the object's maximum height? Uh-oh. I just answered both questions A and B. I'm not paying attention. Paterno, 3 seconds was the answer to question A. 184 feet is the answer to question B. Question C, how long will it take to hit the ground? So we're looking for this point over here. Okay, that's the time of the x-intercept because the ground is at the height equals 0. Okay, so this is an x-intercept over here. Let's see if this equation is factorable. I'm starting to think that this is not factorable. Let's use quadratic formula. All right, x, where's my formula? X equals negative b plus or minus square root b squared minus 4 a c all over 2a. Right, 96 squared is 9,216. This is a negative times a negative. It's going to be a plus here. 2,560 all over negative 32. Negative 96 plus or minus. Now I'm going to add those two together. 9,216 plus 2,560. 11,776. All right. Let's now see what the square root of 11,776 is. It's 108.5. All right, so I'm going to break this down into two separate answers. So one of them is I'm adding 108.5, and the other one, I'm going to subtract 108.5. And by the way, let me just talk about why I'm using a decimal here, where I would usually make you put it in simplest radical form. The answer to that is just because this is a real-life problem. All right, so now I'm going to add the numerators. Negative 96 plus 108.5 is 12.5. Divided by negative 32. And over here, negative on the right, negative 96 minus 108.5 is negative 204.5. One last step here. I'm going to divide by negative 32. So 12.5 divided by negative 32 is negative 0.39. And negative 204.5 divided by negative 32 is 6.39, positive 6.39. Okay. So I'm going to just take a look at these two. This is the time. I think this was in seconds. Let's see the original problem. Yes, this is being measured in feet per second, and so therefore our answer is in seconds. Okay. And looking at the parabola that I drew, over here you see this would be before we started counting, because this point right here, the negative one, because we started with the object already being 40 feet off the ground. This point over here is the positive one, and that's answering the question, how long does it take to hit the ground? So 6.39 seconds, that's your answer. Okay.